channel. Today let us learn about a new topic, balancing equations. So before dealing with this topic, balancing equations, let us see a law. This is law of conservation of mass. So what this law says? So this law states that either energy or mass cannot be created nor destroyed. So the meaning of this law is that any mass or energy cannot be created by us or it cannot be destroyed. Whatever is there in the universe will always be there. If 10% of energy or mass is present in universe, means this 10% will always be there. You cannot add extra 1% or you cannot deduct extra 1%. It will always be 10%. So this is what the law of conservation of mass is stating. So now let us look how this conservation of mass law is used in our topic, balancing equations. So the word balancing states that the meaning of this balancing is equal. So balancing equation says that a chemical equation will always be balanced. A chemical equation will always be balanced. So in what way a chemical equation is being balanced? A chemical equation is nothing but one or more reactants will react. So here we will be having in our left hand side reactants. So here one or more reactants will react to give final products. Even the product can be either one or it can be more than one. So here reactants are reacting to give products, either one or more. Suppose if we have taken 10 grams of reactants, 10 grams of reactants if we have taken and made it to react, we will be getting product of 10 grams only. There is no addition of 1 gram or there is no deduction of 1 gram. So this is what the law of conservation of mass also says. So this is what even the balancing equation says. The number of moles of reactants will be equal to the number of moles of products. So this is what is the definition for balancing equations. So let us take an example of this equation. So let us take this as an example for balancing the equation. Zinc is reacting with sulfuric acid in order to give zinc sulfate and hydrogen. Now, these two, zinc and sulfuric acid, are reactants which are on left hand side. Always in a chemical reaction, the left hand side will be reactants and right hand side will be products. So here zinc and sulfuric acid are reacting to form the products. So reactants are zinc and sulfuric acid, whereas zinc sulfate and hydrogen are products. So these products are on right hand side, RHS. Done. Now let us balance this equation. Zinc, the element form of zinc is Zn and zinc is reacting with sulfuric acid. So the molecular formula or the chemical formula for sulfuric acid is H2SO4. So these two are reacting to form a product. So what are those products? It is zinc sulfate. Zinc Zn, sulfate SO4, zinc sulfate plus hydrogen H2. Now this was our word equation. This is our molecular equation or elemental equation, where each and every element is written in its elemental form or chemical form. Now our work is to balance this equation. Now let us look zinc. Here zinc we have now when we look for zinc is only one. There is 1 mole or 1 molecule of zinc present here. In this entire LHS, if you see, there is only 1 zinc present. Now, similarly, when you see towards your RHS, towards your products area, you can see only 1 zinc is present. Correct? Here also it is 1, here also it is 1. So, zinc, here it is 1 zinc, here it is 1 zinc. So, zinc is balanced. Done. Next, H is 2. Here we have 1. 2 ones is 2. So hydrogen we have 2. Zinc was 1. So here also zinc was 1. So zinc is balanced. Here in this entire reactant side, hydrogen is 2. Here 2 ones are 2. So here towards our product area, hydrogen is 2. Let us take another example. Fe plus H2O. These two are reacting to give Fe3O4 plus H2. So this is a chemical reaction happening between iron and water. When iron Fe reacts with H2O water, it will give Fe3O4 and H2. So this is our chemical reaction or chemical equation. So now we are supposed to balance this particular equation. Now let us start with Fe. Fe, here we have only 1. So number of Fe is only 1. Here when we look, we have 3 Fe. So here it is 1, 3 ones is 3. We have 3 Fe. So we have to make this, and here on our LHS side and on our RHS side, the number of molecules should be equal. So here we have 1, here we have 3. So here we have to make it 3. So we will write here as 3. So now this is balanced. We have 3 Fe and 3 Fv. So now Fe is balanced. Now let us go for hydrogen. Here we have 2 hydrogen molecules. Here we have 2 hydrogen molecules. Hydrogen is balanced. Now let us look for oxygen. Oxygen is only 1 towards our LHS part. When we look for RHS part, oxygen is 4. So now oxygen is not balanced. We are supposed to make this oxygen to 4. So that is why we will write here as 4. So now 4 ones is 4. So oxygen became 4. Oxygen got balanced now. Fe is balanced, oxygen is balanced. But now hydrogen, which was 2 initially, now it has become 8. 4 twos is 8. So now hydrogen molecule number has increased to 8. But here it is only 2. So we are supposed to balance this. In order to balance this, we will increase hydrogen molecule number over here. So 2 with which number if we multiply we will get 8. It is 4. So 4 twos is 8. So hereby hydrogen molecule is also balanced. So Fe is balanced, hydrogen is balanced, oxygen is balanced. So this is how you will balance the given chemical reaction. Now let us move on to types of chemical reactions. So this is our subtopic under this chapter. So when we look into types, we have 5 different types of chemical reactions. First one is combination reaction. Second one is decomposition reaction. Third one is displacement reaction. Fourth one is double displacement reaction. And the fifth one is oxidation and reduction reaction. So these are the 5 different types of chemical reactions. Now let us look into each and every reaction in detail with an example. So now let us move on to the first chemical reaction, combination reaction. So this is our first type of chemical reaction. So let us look into this word combination. Combination means to combine. To combine, or you can say to add. So here what happens in this reaction is two or more reactants will join together or will get added to give one single product. This is a general information about combination reaction. Combination means to add or to combine. So here in this reaction what happens is two or more reactants will combine together or they'll add or join together to form one single product. Now let us take an activity which is given in your textbook. Consider a beaker. You have taken a beaker and you are adding quicklime to it. This is your quicklime. You have added. Next, you are adding water. Next, you are adding water to this. So now, to this quicklime, when water is added, there is certain chemical reaction happening. Chemical reaction happening between these two, and at last a product will be formed. Now let us look what is that chemical reaction happening and what is the product formed and which type of chemical reaction is happening in this particular activity. First we added quicklime to the beaker. Next, to this quicklime we added water. And after adding we got a product. What is the product when you add quicklime and water together? What is the product we'll be getting is slaked lime. You'll be getting product as slaked lime, plus along with this product there is some amount of heat energy produced. How can you get to know that heat is produced? You can get to know whether the heat is produced or no by touching the beaker. Whenever you touch the beaker, because of the chemical reaction, the beaker gets heated up. So when you touch it, you can feel that hotness. That is how you can say yes, heat is produced. Now let us write it in a chemical formula. Quicklime is CaO. It is calcium oxide. So this quicklime is reacting with water to give slaked lime. Slaked lime is CaOH twice. It is calcium hydroxide. So along with the product slaked lime or the calcium hydroxide, we are getting heat which is produced. So here we can see these two reactants are reacting together, they are adding together to form this one single product. So this is called as combination reaction, where these two are combining to form a single product. We are getting only one single product. Here heat is produced. So this is an example for combination reaction. So in the previous reaction we saw that heat was produced, correct? When quicklime reacted with water, it gave out calcium hydroxide, which is slaked lime, and heat was produced, we said. Now a reaction, this is important, a reaction in which heat energy is produced. A reaction in which heat energy is produced or given out is called as exothermic reaction. So a reaction in which heat energy is produced or given out is called as exothermic reaction. Now there is another type of reaction which is important. A reaction in which heat energy is taken or consumed is called as endothermic reaction. So a reaction in which heat energy is taken or consumed is called as endothermic reaction. As the name says, exo means out, it is given out. Endo means inside, it is taken inside. So a reaction which will give out heat energy is called as exothermic reaction, and a chemical reaction which requires heat energy is called as endothermic reaction. So these are the two types of chemical reactions, a general type of chemical reactions. It is exothermic and endothermic reaction.